37. Artificial neural network, AN. A model inspired by the structure of the human brain, with interconnected neurons. Composed of layers of nodes that process and transform data. The fundamental building block of all deep learning systems. Learns by adjusting the weights or strengths of the connections between neurons. Can model extremely complex, nonlinear relationships in data. 38. Neuron, node. A single computational unit in a neural network that processes and passes on information. It receives inputs, applies a weight to them, and passes the result through an activation function. Like a single brain cell, it's simple on its own but powerful in a network. The basic building block that is stacked into layers. Its output is a signal that gets passed to neurons in the next layer. 39. Activation function. A function in a neuron that decides whether it should be activated or fire. It introduces non-linearity, allowing the network to learn complex patterns. Without it, a neural network would just be a simple linear regression model. Common examples include ReLU, sigmoid, and tanh. It acts like a switch or a dimmer, controlling the signal flow. 40. Weights and biases. The learnable parameters of a neural network that are adjusted during training. Weights control the strength of the connection between two neurons. Biases are like the y-intercept, allowing a neuron to shift its output. Gradient descent is used to find the optimal values for these parameters. All the knowledge of a trained neural network is stored in these numbers. 41. Backpropagation. The algorithm used to train neural networks by calculating and propagating errors backward. It figures out how much each weight contributed to the final error. It then uses this information to adjust the weights with gradient descent. It's the engine that makes deep learning possible and efficient, propagating errors backward from the output layer to the input layer. 42. Convolutional neural network, CNN, a specialized type of neural network designed for processing grid-like data, like images. It uses filters, or kernels, to scan for patterns like edges, corners, and textures. The backbone of modern computer vision systems for image classification. Its architecture is inspired by the human visual cortex. Can identify objects in pictures, videos, and even medical scans. 43. Recurrent neural network, RNN, a type of neural network with a memory that is ideal for sequential data. It processes data one step at a time, keeping a hidden state of what it has seen. Perfect for tasks involving sequences, like text translation or time series analysis. Traditional RNNs suffer from the vanishing gradient problem for long sequences. It's like reading a book. It remembers the previous words to understand the current one. 44. Long short-term memory, LSTM, an advanced type of RNN that can remember information for much longer periods. It uses a system of gates to control what information to remember or forget. Solves the vanishing gradient problem of simple RNNs. Was the state of the art for many natural language processing tasks before transformers. It's a crucial architecture for time series forecasting and speech recognition. 45. Transformer, a powerful neural network architecture that revolutionized natural language processing, NLP. It uses an attention mechanism to weigh the importance of different words in a sentence. The foundation for models like GPT-3, BERT, and other large language models. Unlike RNNs, it can process all words in a sentence at the same time. Has become the dominant architecture not just for NLP, but also for computer vision. 46. Generative AI that can create new, original content, such as images, text, music, or code. Models like DALL-E, images, and GPT, text, are prominent examples. It learns the underlying distribution of the training data to generate new samples. It is transforming creative industries and how we interact with information. It's not just analyzing data, it's synthesizing something brand new. 47. Generative Adversarial Network, GAN, a type of generative model with two competing neural networks, a generator and a discriminator. The generator creates fake images, while the discriminator tries to spot the fakes. This competition forces the generator to create incredibly realistic outputs, used to create deepfakes and generate photorealistic faces of non-existent people. An elegant and powerful idea that has pushed the boundaries of creative AI.